The northwest coast of Indiana along Lake Michigan is a vegetatively rich and dynamic part of the United States, with some of the most diverse ecosystems in the country. This region is home to around 30% of Indiana's listed rare, endangered, or threatened species, making it a highly volatile area with the increase of erosion, global warming, and industrialization. Dune erosion has continuously been a threat to the surrounding communities as homes, roads, properties, and plant communities are at risk of being destroyed from displacement of sand and rising lake levels. This capstone project focuses on the three major communities along the Indiana Dunes: Beverly Shores, Dune Acres, and Ogden Dunes. The disruption of sand transportation has largely been due to the Michigan City Piers and Burns Harbor, as it blocks the natural transport of sand through water and wind. Human interaction with the dunes has also contributed to erosion issues, as residents and visitors to the Indiana Dunes National Park partake in recreational activities on the beach. The shoreline conditions along Lake Michigan have always been changing, and dune erosion has been an issue ever since these communities were first created. However, the same methods of erosion control, such as breakwalls and boulder revetment, have been used continuously over decades, yet they always fail in some way and need to be rebuilt. This leads to the proposed question of what new, more sustainable and effective erosion control methods can be used along the lakeside. To answer this question, it is important to analyze the current shoreline ecological and structural conditions in each of the three communities. As seen with Beverly Shores, erosion is mainly caused by high prevailing winds from the east, which strips existing beaches of its sand and moves it westward down the coastline. Shown in this analysis are the wind speed ranges, ranging from high to medium in Beverly Shores. Wind speeds are generally higher due to the community taking the brunt of much of the lake winds. Where wind speeds are higher, duneland is most likely to erode, and the existing vegetation along with it. Vegetation is needed for sand to stabilize properly, yet with constantly eroding sand, vegetation cannot grow. This cycle repeats and creates an unhealthy dune. This analysis was used in the other two communities to gather data on better erosion control techniques. Each shoreline is different, so keeping a list of erosion control method options is important for helping dune growth and health. The most successful and healthiest erosion control method is vegetative restoration, replanting the dunes to keep sand down and help environmental health. This option is not always the easiest, however, as it takes time to grow, but with small implementations it can be used. Other methods of erosion control include living breakwaters and pocket beaches to help with sand movement and deposition. To find what areas in each community are best to place new erosion control methods, certain factors must be taken into account. These include slope analysis, existing control methods, sand accretion and erosion, property types, existing vegetation, and current beach size. Based on these factors, areas along the coast were rated from high to low in terms of best areas to place new methods. This process was also used for Beverly Shores, Dune Acres, and Ogden Dunes. For Beverly Shores, I have proposed the major erosion control method of living breakwaters, utilizing concrete reef walls to disperse wave energy from hitting the shore hard, controlling the deposition of sand, and creating new habitats for lake aquatic life. The long-term goal of this design aims to create a more stabilized beach along this section of the coast and reduce energy that hits the existing shoreline. It is important to note that with these designs, the design of these projects that will require a lot of site-specific, intense data and engineering to be successful. This lake has many constantly changing conditions, like water level, which makes designing more difficult. These design goals are what I hope to accomplish, but there's always this caveat. For the Dune Acres community, my primary intervention is a proposed pocket beach to tie into the existing public beach access to the east of the site, building upon that programmatically. With more existing and stabilized beach, this area presents an opportunity for plant rehabilitation with dune grass. This area could also benefit from blocking off unnecessary footpaths and human foot traffic through protective fencing and signage to keep people away from the replanted dunes. Lastly, in Ogden Dunes, I have proposed the use of both vegetative restoration through brush layering, as well as the implementation of a community pollinator garden next to an existing pavilion. Brush layering is an ideal for steep and eroding shorelines and utilizes live cuttings from trees like willows or cottonwoods to add structure and a living and growing vegetative element to an otherwise bland terracing method of erosion control. The Community Pollinator Garden offers an opportunity to educate residents and visitors on the importance of dunes, dune health, and erosion along the lake. Implementing new erosion control methods is important to the Indiana Dunes communities along Lake Michigan, as it offers a solution to a decades-long problem of erosion and degrading dune health.